This podcast is recorded at the University of Sydney's Camperdown campus on the land of the Gadigal people of the Eora Nation. They've been discovering and sharing knowledge here for tens of thousands of years. I pay my respects to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people. What if the light around you, in your office, your bedroom, your phone, was quietly reshaping your brain and your mood? Inside each of us is a biological clock, an ancient system that keeps our bodies in rhythm with the sun. It determines when we feel alert, when we sleep, and even how our organs function. But today, those rhythms are off. We spend our days indoors, stay up long after dark and live by social schedules rather than solar ones. Increasingly, researchers believe this disruption is not only affecting our sleep and mood, but is also linked to serious conditions like depression and bipolar disorder. What happens when our circadian clocks fall out of sync, and how can we bring them back into balance? This is The Solutionists. I'm Mark Scott. Dr. Jacob Crouse is a mental health researcher looking at how circadian clock disturbances and related biological factors influence some types of mood disorders. Jake leads the clinical stream of the Youth Mental Health and Technology team at the University of Sydney's Brain and Mind Centre. Now, Jake, biological clocks are at least 2 billion years old. Why have organisms developed the ability to tell the time internally? And how does it work for humans?
So, telling time, hundreds of millions of years ago, when the Earth was an extremely unpredictable place, helped animals and other organisms survive. So they were able to tell what time of day it was most useful to be going out foraging for food, mating, reproducing, and resting, and basically trying not to be eaten by predators. So the 24-hour light-dark cycle is one of the most predictable patterns in our environment. And it really functions like a clock itself. So it makes perfect sense that our biology mapped onto that 24-hour cycle of light and dark as a way to tell time, so to organise when physiology should be happening and when rest should be happening. And that kind of happened by chance, just a fluke of evolution, but it was so important for physiology, for survival, that we see it in basically all life forms now. So there's kind of not an organism that we can study that doesn't have this circadian clock mechanism. And it's very conserved across many species. So we all have that kind of basic fundamental clock, no matter what kind of organism we are.
So our body knows what time of day or night it is and is constantly changing in response to that.
Absolutely. So it's a bit like an analog old-time clock, actually. So you would think that, the 24-hour cycle of light and dark would produce a clock in us that's 24 hours, but it's not quite that. The average clock is actually a little bit longer, 24.2 hours, and people have longer clocks and shorter clocks. So that tells us something very important, that our behaviour means we need to set that clock each day. We need to be very vigilant about making sure that the clock is running on time.
I'm going to ask you how you do that later, Jake, but before we get to that, just explain to us a bit more about how our biological clocks synchronise with the sun. How does our body know what time it is?
So about 25 years ago, scientists discovered an entirely new class of photoreceptors in the eye. So we know about things like rods and cones, which tell us about the shape and colour of things, movement in the environment. And that's kind of about our conscious visual world. But there's this new class of photoreceptors, which are called IPRGCs, or intrinsically photosensitive retinal ganglion cells. And those are an unconscious system. And they're really sensitive to light, but not in a visual way, but in a timing way. So those IPRGCs in our retina connect directly into locations in our brain that tell us what time it is. And they connect to a part in our brain which is called the suprachiasmatic nucleus, just a small bundle of cells, very, very few neurons actually. And that's where the master circadian clock sits. So light from our eyes transmitted directly to that master clock. And that clock is actually connected to trillions of clocks all throughout our body, in all of our organ systems, and it's kind of a conductor of an orchestra. we have all these different rhythms going on in our body at all times. And we really need the light signal to tell the master clock what time it is, to tell the rest of the body what time it is.
So in Australia, it's the time of year we'll be thinking about summertime and longer days. And does that mean that we're constantly recalibrating? Because how much daylight there is changes every day, and it's changing through the seasons and through the year. So is this a constant sense of development and adaptation in our bodies?
Yeah, absolutely. So we're adapting every day and across the seasons, and there's a real important metabolic element to that as well. When we were evolving, there were periods in the year where we didn't have access to food. So we needed to change our metabolism about how we're processing and storing food. And that's controlled by, or signaled by the light-dark cycle about that. So yeah, seasonal changes, we're always adapting to that. Some of us feel a lot better come springtime and summertime. In some conditions, people actually feel a lot worse as well. They're very sensitive to that, and it can kind of make their mood more unstable.
And as an expert on circadian rhythms, does that mean you're vehemently opposed to this sudden shift of an hour in daylight saving?
Yeah, that's a tricky one. I've kind of told myself not to talk about this anymore because it causes me trouble at home. Yeah,
because people love daylight saving, but a scientist like you, is it a big body adaptation?
It is, yeah, and it's very complicated and nuanced. It depends on where you are in the world, what your kind of latitude is. So there's no simple fix. A lot of the chronobiology world are very strongly advocating for doing away with daylight savings time, but it actually needs to be quite a nuanced policy change around where in the world are you, because time zones, somewhere in China, they have one single time zone for a huge landmass. So what do you do about a change like that in a country like that?
It's a big issue, but we'll leave it to them. Let's talk about, you were talking about the sun clock and the biological clock. What about the social clock? What is the social clock?
So we always, when we're telling young people with mood disorders about these issues, we're always thinking about the alignment of the sun clock, your body clock, and your social clock. So that misalignment between those is really what's causing trouble. We didn't always have electric lighting. So before that, we had less circadian disruption happening. But with the invention of modern lighting, we can turn lights on all the time, and that confuses our body clock. So really our social schedules are what determines. So these are things like work, social activities. This determines our light exposure in many ways. And we see a lot of people with this phenomenon of social jet lag. So it's kind of like going overseas and becoming jet lagged, which is a state of confusion in your body clock. You're in a new time zone, you're in a new setting of light exposure, which is now out of sync to your internal time. And that causes problems, but you adapt to it. But social jet lag is this concept where you have these social schedules. So you're maybe going to work 9 to 5, Monday to Friday, and then you stay out late, you sleep in on the weekend. And this creates kind of a pattern where you're almost like traveling between time zones in that kind of way. So you're getting later light exposure in the day and the evening, and that can confuse your body clock as well. So a lot of what we try and do is tell people to control what they can control, their own behaviour around light. But there are some problems as well with just broader policy infrastructure around work schedules that some attention needs to be paid to as well.
So if someone's out of sync, out of rhythm with the sun, how would you notice that? What would you see in them?
Yeah, so obviously you feel tired. One of the first things to go is your sleep. Your sleep quality is fragmented. We often explain this as a kind of a state of jet lag. So your body feels just out of sync. It doesn't feel right. You have low energy. You have trouble concentrating. Many of these things are part of modern life. I think many of us feel that way, and
we're all feeling slightly condemned as you speak here, Jacob.
Yeah, for sure. And we counteract these things with caffeine, but don't really pay attention to things like light, which is readily available. I mean, a few years ago, I didn't appreciate that light is very active. It transforms our brain, our neurobiology, and we can use it as a tool. So, yeah, we often see people feeling sluggish, cognitive problems. And
when you're talking about light, you're talking about sunlight. What about light in the room we're in now?
Yeah, so it definitely depends on, there's always a thing about time of day, the intensity of the light, and the wavelength or the colour of the light. So it's a complicated story as well around daylight or light during the day, very good for you. Light at night, not so good for you. So, the sun is the strongest source of light. We can go outside and be exposed to like 100,000 lux, which is very powerful light, sends a very strong signal to our clock. Rooms like this, we're talking about, a couple hundred lux, so much slower. And most of us spend most of our day in these kind of settings, and that's just such a weak signal where our body clock's just trying to guess, what time is it? We didn't have these kind of LED fluorescent lights when we were evolving, so it's caused a real confusing picture.
So, if our body clock is out of sync, we're feeling tired, we're feeling sluggish. But are there further harms than that? Is it something to be concerned about if we spend a long period of time in that state?
It is. So we're learning more and more that circadian clock disruption seems to be a cause of many mental and physical health problems. We work mostly in mental health, in mood disorders, but we also see physical problems in many of our people with mood disorders that we think could be explained by circadian disruption. So some of these things are hard to work out because you can't make someone sick on purpose. There's an ethical dilemma there. But there are studies that show that when you take healthy volunteers and put them into a situation where you're disrupting their circadian rhythm, you put them on a weird light-dark cycle or give them light when they should be sleeping, you can cause negative changes in their mood. You can cause changes in their sleep, and also things like insulin, glucose tolerance, so things that are related to diabetes. So there's kind of evidence in that type of setting, but then there's a lot of epidemiological studies as well that do link circadian disruption to Alzheimer's disease, dementia, cancer, cardiovascular disease, metabolic illness, bipolar depression.
Wow. All right, we better be paying attention.
Yeah.
That sounds serious. Tell us about the work you've been doing on the relationship between circadian rhythm and bipolar disorder. Just firstly, a definition. So how are we defining bipolar disorder?
Yeah, so this is something that a lot of people get wrong. So people often think that bipolar disorder means that someone has two personalities or they can't control their mood. But bipolar disorder really is a severe mental disorder. It's very chronic and lifelong for many people. And it's about very extreme changes in mood. So it's a mood disorder. But more fundamentally, it's about energy and motor activity. So when people are manic or hypomanic, their mood, energy, activity turned way up. When they're depressed, that's all turned way down. When we talk to people with bipolar disorder, some of them tell us, you've got the label wrong. I don't have a mood disorder. I have a movement disorder. I can't get out of bed. So that's what bipolar disorder is for a lot of people. And there's a recognition increasingly that fundamentally, bipolar disorder is a very complex illness. It seems to be multi-system, so it's not just about the brain, but it's about many systems in the body. But fundamentally, it could be a body clock disorder for a subgroup of people. Their body clocks seem more brittle. They're more fragile. So around the seasonal change, we see a lot of people with bipolar disorder become very vulnerable around that time, and clinicians know that. They know that they need to pay special attention to a lot of their patients around this time. So there seems to be some vulnerabilities there.
Is there a hypothesis on that? Why would that particular time of year be difficult?
Yeah, so the hypothesis is that that's the time of year when light has the most rapid change. So as you said before, light's changing year-round. We're always adapting to that. It doesn't affect everyone. It doesn't affect everyone with bipolar disorder or depression, but there's a subgroup, and these people may be more light sensitive. So that's another point, that there's huge variation in how sensitive we are to light. And you can't know that about yourself. We need to develop ways to measure that. Yeah, so for a lot of people, it seems to be about light changes very rapidly and then they become more unstable, so their body clock's affected.
So what are some of the clues that you see in people living with bipolar disorder? What about their circadian rhythm stands out?
Yeah, so before someone's becoming unwell, they're becoming manic or depressed, one of the first things to go is their sleep. So that's kind of an early warning signal that something's going on. Sleep's also a complicated process that's linked to body clocks, but it's also its own thing as well. But people, when they're becoming manic, tend to need, well, they say they need less sleep. They can get by on less sleep, and sometimes they go days without sleeping. So there's something about the signal going wrong there. We also see that their sleep-wake timing becomes much more irregular. So their kind of natural bedtime seems to become more delayed or advanced. So there's something about they're not syncing up as the rest of us should be. And then when we get them into the laboratory, so we have studies that are kind of like an environment like this, but a little bit dimmer, where we cut off all the circadian cues. So things like light, We control feeding times. And we look at people's body clocks, so their melatonin or their cortisol, core body temperature. Those things can become very delayed or advanced, or the rhythms are very damp. So there's something strange going on internally for those people that suggests their body clocks are out of whack.
Tell us about having people in that kind of lab environment. How long do you have them for, and are you monitoring them for all that time?
We tend to do these things just over a kind of a 24-hour period. So we've got a study going on at the moment, which is running for 24 hours, and we're doing very frequent saliva and blood samples. And that's in healthy volunteers. You've got to be really careful with people with health conditions. So when we get people with mood disorders in for these studies, typically we'll get them in about 8 hours before bedtime, and we'll be taking saliva. We might get them to swallow a special pill that measures their body temperature. And we're keeping them awake for a couple of hours past our usual bedtime, which is really key for catching that melatonin rhythm turn on. So that's one of the key signals that tells the body that it's time for bed. And then, keeping them overnight, measuring those things kind of throughout the night where possible, and sending them home the next day.
If the link between circadian rhythms and mood disorders is as strong as it seems, as you outline, what could treatment look like of these disorders in light of that insight?
Yeah, so that's been a really transformative area. So there's a whole suite of therapies which are called chronotherapies. So they're all about time, setting time, making things more regular. And they tend to come in a few different flavors. So there's things like light therapy. So there's a kind of a formal intervention that gets people to sit in front of a bright light box, which is basically trying to mimic sunlight. And, if someone's depressed, they might not want to leave the home. So having that option to just sit in front of something that's kind of like the sun and sets their clock. So clinical trials show for people both with unipolar depression as well as bipolar depression, so people that go up and they go down, or people that just go down, that bright light therapy has antidepressant effects. So it's kind of a natural antidepressant. There's also another type of therapy called dark therapy, which is kind of the opposite. So in the early days, studies would put people basically into a dark room for a prolonged period of time. These were people with typically bipolar mania, and they would let them kind of deactivate, calm down. And those studies are also quite challenging to do and very hard to fund, so they're not as popular, but they do show that people can kind of come back from mania if you put them in those settings.
So circadian rhythm disturbance can be devastating for people with bipolar disorder, but what are the effects for people without a mood disorder? What does this disturbance do to them?
It affects everyone. It's just a fundamental aspect of our biology that was so important for our survival. So it'd be very surprising if it wasn't affecting all of us. We live in a light-polluted society, so not only do we get low daylight exposure, light's also way too bright at nighttime, and that confuses our clock. So I think really hundreds of millions of people around the world are affected by these things in subtle ways sometimes, but these disturbances might also push people over thresholds to developing illness. And studies are starting to measure circadian disturbance at large population levels, so using things like wearables. You can get an idea about someone's body clock from a wearable. But the research just hasn't really been done to look at the whole variety and spectrum of illnesses. So we do have evidence now that light circadian disruption affects heart disease, cardiovascular disease, metabolic illness. But we think these things are affecting everyone.
So you're saying that this circadian rhythm disturbance can affect everyone, that it's kind of deeply built into our evolutionary state.
Yep.
But it can have some harmful effects. So what are we going to do? So give us some tips on how to remain at the top of our game despite all the pressures of modern life that affect us in this way.
So I think one of the first things is this mantra of bright days and dark nights. Keeping that in mind as you go about your busy life, and kind of thinking about it as you do with your diet or your exercise, and just kind of keeping it in mind. So we evolved when life on Earth was very bright in the day and very dark at night, and our body clocks haven't adapted to modern life. So we need to go back to some of those rhythms. So you need to also keep in mind things about the timing of light, the intensity of light, and the color of light without overcomplicating things. So in my own life, I get up in the morning and I get straight outside, go for a walk. You know, on a very bright, nice day like today, you only need 10 minutes or something like that. But people are differ in their sensitivity, so you can spend 20 minutes outside. And that's the best way to send a signal to your clock that it's daytime. Also, throughout the day, we tell people to take circadian light snacks. So just getting outside for coffee, having your lunch outside, spend some time by a window, and just sending a signal to your body that it's still daytime.
And is that because if you're working indoors without much natural light, your body might be confused as to what type of day it is?
It can get to that point, or that you haven't sent a strong enough signal. So it's about kind of maximising the signal throughout the day, and your body clock is always just trying to guess what time is it, and it's thinking about how much light have I gotten today. It's counting photons. So you just want to maximise that. So, and that can also offset the negative effects of light at night. So there's also this thing about we have this new invention of electric lighting, and if it's nighttime, the sun's down, and then you expose yourself to really bright light, that's very confusing for your clock. It now thinks, oh, is it actually daytime? And it starts to change what it's doing. So it reorganizes its timing, and actually about half of our genome cycles on a circadian rhythm. So it's affecting every system in our body. So we want to have these bright days, and then when the sun goes down, think about what kind of lights you've got on in your home. So you want to be able to see. So you might think about changing, if you have to have lights on, changing the bulbs to be maybe warmer bulbs. There's also smart bulbs. So I have a system now that's hooked up to my Wi-Fi. I don't have to think about it. When the sun goes down, my light changes a little bit.
What about screens?
Yeah, screens is very controversial. I personally think that that's been overblown. I think that the light, so there's this whole thing about blue light. Blue light's good for you. You want blue light during the daytime. You know, people wear blue blocking glasses when they're on their screens during the daytime, which, you know, reduces eye strain, but I think it's gotten a bad rap. Your circadian system's most sensitive to blue light. So that's where this problem with screens comes in, because they can often be quite blue. But in my view, and some of the science seems to say that light from screens just isn't bright enough to have a real impact. It's probably more about overhead lighting. That's the problem. And I think the link between screens and sleep is potentially more about the content of what's in those. So if you're reading
stimulating
the news,
content of it, right?
Hearing about what Donald Trump just said, or that affects me.
Yeah. So watch out for the overhead lights, more lamps, you know, and dimmer, but keep an eye on the screen. So they're all good things for us to do individually. But what about as a society? You know, we're operating in these cities and in these workplaces. How should we be thinking, in a sense, at a higher level, at a society-wide level around some of these issues?
Yeah, that's a really critical issue. So there are studies that now they use satellites or they use wearables and have linked the light exposure in neighbourhoods to people's risk of illness. So, you know, more artificial light in a certain neighbourhood being associated with more depression or bipolar disorder, things like that. So that's coming from, you know, street lights, and I think there's a real argument to be made for protecting people, you know, maybe subsidising people to have blackout blinds in their homes. There was a study recently that showed in songbirds that birds are staying up later as well. You know, they don't have devices, or they're just staying up later because it's bright outside at nighttime. So we see these things in ecology. It's affecting humans. So I think there is a real need to think about light pollution at night. And these things also disproportionately affect disadvantaged communities. So I think we do need to advocate more for protecting people in that way.
We've talked about bipolar disorder and depression, but what are the other benefits that accrue to us through exposure to strong natural light through the day?
Yeah, so we're also learning about these kind of more direct effects of light. So these pathways from these special cells I mentioned in our eyes to other regions in the brain that kind of go around the clock. So they kind of bypass the clock. So we're learning that your exposure to bright light during the day changes how you think about yourself. So maybe it means you spend less time kind of ruminating on the negative aspects of yourself, and that's a really good thing. It also changes maybe how impulsive you are, and some settings use this, you know, gambling settings use this in a maybe nefarious way, but there's a lot that we can learn about improving people's mood and alertness in office settings and improving productivity that way.
Many of us can measure how we sleep now. I suspect I read a review of my sleep, as one of the first things I do every morning. Is that a good thing?
Yeah, I think for most people the answer is yes. Knowledge is power. All of this stuff is around personalization, experimenting, seeing what works for you. We find in our clinical settings that people want to know, what does this mean for them, for their behaviour, for their environment, their home, and what does it mean for their mental health and well-being. So the only way to really get at that is through measurement. Measuring body clocks inside of us is very hard, outside of these very dungeon-like laboratory settings. But things like wearables can get us some of the way there. So Fitbits, Garmin's, Apple Watches, they do give us important information. I think the most important thing is about the regularity of your sleep-wake timing from those devices. So they try and tell you things about sleep stages, and I don't think they're quite there yet, but they do have a decent measure of what time did you go to bed, what time did you wake up, and you want to be looking at how regular that is, and I think that's more important.
And consistency is really important with that.
For sure. And that's the best way to send that signal to your clock every day, helping it guess what time it is. I think also there's some caution needed. Some people are anxious about their sleep, and that's a common cause of anxiety. Freaking out about sleep makes your sleep worse, and it's a cycle. So more information isn't always better. There's been some clinical trials that show that if you give people the opportunity to sleep a full night and you give them false information about their sleep, you say that they slept very poorly, they actually perform worse on cognitive tests. And so, we can think our way into feeling worse about things. So got to see what works for you.
So, Jake, you're a sleep expert. We're all a bit tired. So just quickly again, what do we need to do now? What do we need to do next weekend to help us manage this better?
Yeah, so it is a lifelong thing. You need to keep your body clock healthy for the rest of your life. It's really about bright days, dark nights. When you wake up, get outside, get in the light, tell your clock it's daytime. When it's nighttime, turn things down as much as you can, turn the lights down. And it's all about, your body clock is adapting every day, and it's just about keeping a kind of consistent rhythm. You're trying to get back to these natural rhythms before we had screens and lighting and office jobs. And yeah, kind of embedding these rhythms in your daily lives.
That's Dr. Jacob Crouse, NHMRC Emerging Leadership Research Fellow, uncovering how our body clocks and moods are connected. And if you're now thinking about changing up the lighting at home so you can get to bed on time, you'll enjoy our episode with Dr. Carmel Harrington, all about improving sleep.
There's quite a lot of subtle symptoms, or sometimes they're not so subtle, that we are sleep deprived. But one of the big things that I like to talk about is, have you lost joy?
You can listen to that episode of The Solutionists right now, and make sure you're following the show so you don't miss an episode. The Solutionists is a podcast from the University of Sydney, produced by Dead Set Studios.